everyone. So the session is on best practices in machine learning observability. Kamal has already provided some introduction, but yeah. So I am Yatin Bhatia, and along with me it's Ankit Rathi. So we have roughly 16 years of IT experience and 8 years in data science. Okay, so agenda of our discussion. So first section will be context and introduction. So what we are talking about, that I will go through, and after that the best practices, the main discussion, the main topic of our talk, that is best practices in ML observability, that Ankit will go through. So let me start with what is ML observability, and then after that Ankit will take over with the best practices. So I will start with some basics, because there can be some newcomers who do not know about machine learning. So what is machine learning, and why the machine learning came into picture? So previously we have traditional programming, in which we have some input, and we have to write some program. Program is what? It's a set of rules, and then some computation happened, and then we got the result. But we have to write the rules ourselves. What machine learning have done, provide the machine learning system as an input, as well as the desired result, the previous results, whatever we have in the past. And then some computation will happen, and this system will itself provide you the rules. Now these rules are the system generated rules, and then after these rules are generated, you can use it further to get the result, because you don't have to generate the rules. The system has generated the rules. So that is effectively a machine learning. I guess broadly the audience knows it, but it is just for setting up the context. Machine learning, it's more than just model training that I have written here in this slide. So what I want to illustrate it is this black box, the rectangular box, it's very small in size. So this is effectively the model training part. The core of machine learning, that's the model training. But if you see, there are a lot of big rectangles on the left side, above, below, right side. So these also are the part and parcel of complete data science paradigm, the complete, getting the requirement and then building the product and shipping the product, deploying the product, a machine learning product, like data collection, feature extraction, process management tools, configuration, monitoring, data verification, serving infrastructure, like at the last level. So we have to deploy the things, and we have to scale up the things. So all these things compute a lot more than just a model training part. That is what illustrated in this particular picture. Yeah. Okay. So while machine learning model is prepared, so now I am going towards our main topic, the ML monitoring, ML observability. So while machine learning model is in production, so many things can happen. So one thing can happen, that is the data drift. So there is a drift in the distribution of the data, like how the data is distributed previously. I am talking in the left side of the picture. I am talking here about the univariate distribution. Like if you see, the distribution of data is like blue earlier, and now it is like red. So there can be like multiple examples in real life. Wherever you will talk, there is always a drift in the data. For example, the drift data which we collect before March 2020, or the lockdown, or the COVID-19, that is altogether different. And the data collected after March 2020 is altogether different. The distribution, the univariate distribution of the data is different. So here, what if data? Data can be like, if you are considering tabular data. So in tabular data, the way the data has been generated, so that can be different. One feature or a combination of features, that can be different. The spending habits of persons or anything, that changes actually. Like how much person spent before March 2020 and after March 2020, that is altogether different. So this shows the drift in the data. Now, why we are considering this, why we are reading this? This drift in the data may cause bad predictions in my model, because my model is prepared according to the blue one. Now data is coming according to the red one. This may cause bad predictions to my model. So it is important for me to understand the distributions of both kind of data. Once my model is in the production, I have to compare what I have done in the training part and what is there in the production part. Accordingly, I have to change my model. Second, on the right side of figure is concept drift. So now what is concept drift? So this is distribution of data, and in here we are considering the output variable as well. Like this is the data, and the green one is the one class, and the red one is the one class. It has been properly distributed, properly segregated, like one class with other class, simple classification scenario. And then this figure, regime B. Here also green as red is there. The data is there, distribution, but the distribution of Y, the output variable, as according to the input variable, has completely changed. Earlier it's like separated vertically, now it's separated horizontally. So this needs to be encountered back into the model. My model has to be retrained, re-engineered, again needs to be prepared. So this concept drift is also very, very important. But only thing is, data drift, you don't have to get the truth labels while you are in production. You can still do the data drift while you are not having the truth data, that the output labels. But for concept drift, the true data is always important, because you need to segregate which is green and which is red. Another example of I have written the short note here. So suppose concept drift of a data variable like mobile number has been changed. So what is the concept here is, so previously I have a mobile number in my data, in my tabular data, and from that mobile number I am able to compute which is a telecom operator for this mobile number. But now what the concept has been changed is, mobile number portability has been introduced into that particular region or that particular country. So previously I'm able to get the mobile number operator through some mechanism. Now when I will get the mobile number operator, I do not know about whether the mobile number portability is there or not, but now I will get the wrong telecom operator. So there is a drift, and that client needs to tell me that there is a drift in the concept. Okay, resolution for it we will cover later, but this is effectively data drift and concept drift. Then data quality, the quality of the data. If the quality of the data changes while I am in production as compared to while I have done the model training part, that also causes issues. Quality is cover each and every aspect. Whether the data is complete, it is consistent, it is relevant, all those things. Business impact. Of course, there is a business impact if there is a drift in the data drift is there, concept drift is there, and my accuracy changes, my F1 score is changes. So businesses will not be happy with that. And I have to change something, because we are getting money for these models, and if models are not behaving properly, we have to do something. Yeah. Okay, monitoring and observability. So monitoring is one thing that you are monitoring the things. Okay, you are getting things, you are viewing the graph. Okay, this has been changed. Data drift is there, concept drift is there. Something has been changed. You are able to monitor it, but observability is more than monitoring. Observability is, you have to do some actions. You have to apply some feedback mechanism, so that next time when the predictions will go on, you will encounter this drift, and then you will again not be in the loop. The predictions are wrong. Next time the prediction should be correct, because you have taken this feedback. So observability is more than monitoring. Observability is like applying feedback back to the model training part. So if you see, there is a arrow from model monitoring to model training part. This is observability. It is not, observability is just like, you got to know what are the things, but now you are applying actions on top of that. If you can see in this figure also, so monitoring is the tip part of the iceberg. Seeing the things. The action part, feedback part is the observability. That is the bottom of the iceberg. That is the main part. So okay, so what are the techniques to do this? So basically monitor the performance of the model. So you have to monitor the drift regularly, data drift, concept drift, any data quality issues. And you have to analyze some metrics. So a lot of metrics are there out of the box. Statistical distributions are there. Okay, in that model training part, you got some metrics like PSI score, population stability index. Your confidence scores are in the range of 70 to 80%. And now in the production, your confidence score are in the range of 60 to 70%. So these are some of the clear-cut metrics, which will give you, okay, there is a drift in the data. Root cause analysis. So you have to determine why this drift has been occurred. So whether business has not told you, or it is something like in the pipeline, something I missed. Apply feedback. The most important part. You have determined the drift, but you have to apply the feedback mechanism, and then so that next time the model will provide the prediction, it will not, it will cause only the good predictions. It will not cause the bad predictions. Yeah, so that's it from my side. So I will ask Ankit, so you can take over from this point. Ankit, you can share your screen,
Okay.
or I can just control the screen. Yeah.
Yeah, sure. Thank you. Okay, so we have learned the basics of machine learning and the need of observability from Yatin, and we'll capture the best practices here. So very first part is the cultural change. We'll go through each point one by one, but I'm just mentioning the outline here. So first part is the cultural change. Second part is monitoring your data, monitoring your models, monitoring your predictions, optimization of the alerts, and logging everything that matters for the solution. So next slide. Okay, so as a part of cultural change, what we need to do is we need to treat the data like a product. So there should be some ownership and accountability where we can track the changes in the data. We can assess its quality, we can check the lineage of the data, we can benchmark the quality, and we can monitor the drift. The second is decentralizing the knowledge. So if the machine learning observability can't be assigned to a single person, because once the solution scales, then it will overburden him. And it is a team effort. There are few things. It's a kind of monitoring plus feedback loop. There are very different stages where we need to take different actions, which would be overwhelming for one person. So it is a kind of team effort where the task needs to be divided among the team on the different part of the solution. Now, including the observability from experimentation itself. So it's not like once we go to production, we deploy the model in production, and then observability come into picture. We need to take care of, if we are seriously looking for model performance and we want to tackle that, we need to take care of observability from the experimentation itself. So another part is monitoring your data. So we need to keep our batch and streaming pipeline similar, because it's like if anything changes to the batch, because the pipelines are built on a similar manner, so we need to apply those changes into streaming as well, because whatever is your training, that data will also go, the similar kind of data will also go for the prediction purpose. And so if we keep the pipelines in the same way, then the troubleshooting will be easier and it will be more intuitive to the overall landscape. Second part is, apart from the data drift, we need to focus on the feature drift as well to get the more insights, because we can have many features and all the data, some of the data elements may be shifting or drifting apart, but those might not be your features, or those might not be your important features. So to basically prioritize which are the features, or which is the data part or the data element that we need to focus more than others. It's like we need to focus on the feature drift than the data drift itself. If we are using data from different data sources, then we need to maintain a global data catalog as well, which makes the data lineage easier. We can understand, means like from where the data elements are coming, how those are being transformed, and in what format those are available to us. We can also track the quality of the data, and it will also help us to measure the baseline of the data quality, so that we can compare with the baseline later on and see, means like whether the data quality has improved or deteriorated. So monitoring your models, when you deploy the model in production, it's not always that it will uh, the performance will keep up to the mark, or maybe it will go up or down. So we need to anticipate that there may be a big dip in the performance, and if we can automate that part, it makes the job a lot easier. Apart from that, we can maintain twin model approach, where we can put the champion model in production and challenger model in pre-prod. Uh, the idea is, because we need to train the model again and again, and not a single strategy work for a longer way as the data drift happens or the scenario changes. So we need to have a challenger model as well, which we can take it up to pre-prod, and maybe like suppose we have updated our model on a weekly or monthly basis, we can put it in the pre-prod environment for some time and see like performance of both the champion model as well as the challenger model. And if like the challenger model is better, we can reverse the role. It's like we can make it champion and put it into production, and the champion becomes the challenger. So it basically takes care of having different models for the same cause, without making much changes post production. Another thing that we can do is we can version maintain hyperparameters for easier troubleshooting, because as the data is in production and it is drifting. So apart from the data version changes, we are also changing our algorithm, and especially the hyperparameters. So if we version maintain them, it will become easier to troubleshoot if anything goes wrong. Next slide, please. Now, another thing is monitoring your predictions. So we need to watch out for the prediction drift, but we can't solely rely on that because not in every scenario we get the ground truth at once. It's like sometimes we get it 5 minutes late, sometimes we get it a day minutes late, sometimes we get a month late. So if we see a drift in prediction, so we can't solely on that we can say that there is a drift and it's a bad thing for our model unless we have the ground truth, and we see the drift there as well. Another aspect is tracking and dealing with the unreasonable output of the model. So we don't have rule-based logics in the models, right? It's like based on the data itself, is it matches the patterns and detect the patterns and provide the output. And if there is something wrong with the input, then output may be very awry for some time. So it's our job to make a note of these kind of unreasonable outputs from the model and put some kind of business logic on top of that, so that it's like it can make more sense for the business user. Now, having logs and alerts gives us an advantage if anything goes wrong. And while we can have the alerts too many or too less, but we need to define what is the optimum level of alerts. It's like if the alerts are too less, then basically we can miss some important alerts which needs to be monitored. And if we have too many, then maybe like some kind of important alert may be get missed into low priority alerts. So we need to basically keep the alerts to its optimum level, and we need to test these alerts before moving to production because of many reasons, so that the team is accustomed to the alerts that is being generated, or the person who is monitoring it knows like what kind of alerts can be generated and how to interpret it and how to take action or raise a red flag on that. And we also need to agree on a format or a what kind of plots and charts are being generated as part of alerts, so that the person who is monitoring it can make sense of it. Another last important aspect is logging everything that matters. So there are few things that we need to take care of, like logging the run times, the number of runs, job failures, and we also need to log the prediction alongside with the ground truth. So it helps really if the prediction is drifting or maybe the model performance is going down, then we can see, okay, what was the ground truth and what was our prediction, and it's like how last month or last day or last week, what was the difference, and now what is the difference. So it helps a lot to make a sense of that. Then logging the data and model version as well, because over the period of time we will be the data will drift, and even we will be making changes to the model as well. So we need to keep a track of the changes in the data and model as well. It will help immensely if something goes wrong and we need to troubleshoot. So basically these are the best practices for ML observability, and we are open for questions.
Thank you so much, Ankit. Thank you so much, Yatin, for your presentation. We have a couple of questions in the chat. Pedro is asking if you're going to share the presentation with us later on in the Talks channel or here in the chat.
We can do.
Yeah, so we can do that, yeah.
When considering, from Alexander Oid, when considering feature drift, what metrics would you recommend to use, and what would you consider significant drift, so the threshold to take action?
So actually that is quite dependent on the problem you are working in, whether it's a classification problem or a regression problem. And the threshold is also defined from the problem itself. When we test the model in a testing environment, then we discuss with the users what are the threshold that should be taken, which are the, when you see the model performance is going down, because it's quite subjective. For some use cases 99% accuracy may be enough. For some use cases 85-80% accuracy may be enough, and somewhere false negatives and false positives, these are also become important. So it's really subjective to the problem that we are working on.
I see Adam has a question, and Yatin is answering on the chat. I go for the question of Adam. Do you have any tips to deal with extremely delayed ground truth? Example, 1 year, particularly for logging prediction alongside ground truth.
Yeah, so that's a good question. Generally, if the ground truth is available as soon as we have made the prediction, it makes the job easier. But yeah, in many scenarios we get the ground truth later on, so we need to log them separately. Once we have the ground truth, the idea is to have the ground truth and the prediction whisk to whisk, so that we can see how much gap is there, and if the gap has increased or decreased over the period of time. If the ground truth is available later on, then basically we can't do anything. It's just that we can maybe monitor the prediction drift itself, but as I mentioned earlier, we can't surely take an action based on the prediction drift alone.
Okay, we have also one here from Jeremy. Great, thanks for your presentation. In Monitor Your Data slide, you said measure the baseline of data quality. How do you define the baseline? What do you measure exactly, for example?
Okay, so measuring the baseline means in the data quality is basically you have a data, and there are various aspects like correctness, truthfulness of the data, how it is varying up across its domain. So there are data quality parameters where we can rank our data, and based on that we can see, okay, for a particular column how much values are null, how much many values are outliers, and so those kind of stats we can collect from the data itself. Obviously these kind of distribution will be different for the variables that are quantitative and qualitative, but basically we can keep a matrix of these as a baseline, that at the initial stage, this is our data quality, so that if anything goes wrong, we can again collect the same thing, similar kind of stats from the data, and compare it with, maybe suppose, just a crude example is like earlier we had 5% nulls in one column. Now we have maybe it's like 20% nulls in a column, and then we can start analyzing why that happened.
Okay, our time is over now. Thank you so much, Ankit. Thank you so much, Yatin, for your talk. If you would like, you can continue the discussion at Gather Town or in the Talks channel. Thank you so much for being at PyData Global 2021.
Yeah, same here. Yeah. Have a nice day. Bye.